Hi there, welcome back to Triplicate, and PCB design, as you can see, is in progress. And despite setting out to do an electronics channel, I don't do too much PCB design. So of course, since about 2 years ago, the last time I used KiCad, there you can see it, I've forgotten how to use it, and it's 2 versions later. So what I'm going to do for this video is just crack on, because it's going to take me a long time, and give you a few progress reports. Okay, so as I said in my short video that I did explaining where I was, what we're going to have is a PCB represented by this piece of stiff paper, which is going to go like that and attach to those mounting holes. Then we're going to have a nucleo like that, and then we're going to have another PCB, and then we're going to have displays etc. on top. Now, I originally intended to have both these the same PCB, and the bottom one just with no electronics on it, is just entirely used for mounting. But let us consider our PCB here. Let's zoom in. So we've got the nucleo there, and we'll just get another display. I had to buy a third display because I blew that one up, blew some segments up. Those go on top like that, and they sit in sockets in pin headers spaced well off the board, so we can get components underneath the displays, and this is below the board like that. However, as you can see, by the time we've got 2 rows of headers here and 2 rows of headers here, it's getting a bit tight. And let's have a look at the components we need to get on there. Okay, so bearing in mind we've got these 2 rows of connectors there, we've got 4 lots of connectors for these there and there, and to this board we have to add a Bluetooth module, a power supply module for the displays, a SD card module, a GPS module, yeah, a voltage regulator to cut the incoming 12 to 14 volts down to 5, an inductor for said switching power supply, and I've got to use a switching power supply because the current draw on this thing is going to be high, so a linear one is going to need a huge heat sink. However, I might calculate it and see if I can do that. And I think that inductor might just possibly be OTT for the application. And where are we? We've got capacitors for the power supply, diodes, Zenas, Schottky diodes for the power supply, fuses for the power supply. I get the impression we're running out of board space here. And then we've got 2 light sensors, possibly about there. And I haven't built these yet, but we've got light bars here, here and here and here and here. And to drive the displays, we've got driver chips. Probably only need 3. And we've got power transistors to drive the colours, the 3 colours, red, green and blue. I don't know about you, but I don't think that lot's going to fit in there. Now you'll notice it's all through the hole stuff that I've got. Due to laziness and not wanting to get the microscope out and start soldering surface mount, but I suspect we are going to have to. Even then, I do not think it is going to fit in that board. Okay, so these are the people I should be getting the PCBs from. We just put in all the defaults. Length, millimeters, 99 by 99, oh, 99, it says 10 centimeters somewhere for the cheapest PCBs. Quantity 5 pieces, you can't get any 2 layers, FR4, thickness and all the defaults here. So now if we calculate what that's going to cost, total $10 US. Can I change the currency on this? So that's an absolutely crazy price, but we've already concluded we're not going to get all our bits on one PCB. So we could have 2 of those for $20 US. Yeah, why not? But then we could try and make a bigger one. We could try and make a bigger PCB. Well, we could make a PCB that fits snugly in the box. We'd have to chop these corners out, but never mind. And that is, shall we say, 12 centimeters, 120 mils. So let's feed that in and see how much that PCB would cost. Okay, so 120 is 119. Just to give a 1,000 millimeter. A millimeter wriggle room. So let's recalculate. And that comes to $40, $39. So I think decision is we're going to, instead of having the 2 circuit boards the same and the bottom one just being for mounting the Nucleo to the backboard, we're going to have 2 different boards, and we are going to mount a lot of the components on the bottom board and a lot more on the top board. So without further ado, let us crack on at that. Okay, got some components down. KiCad is like, I've found all these open source collaborative bits of software. Everybody wants their little feature in, so it's sometimes a bit of a fight just to get it to do really basic stuff. But I've got this far. I've got the 3 driver chips in, the 2 displays in on this sheet, and we can get up to the other sheet. Yeah, that sheet is just those boxes are actually the connectors to the Nucleo, and I put a driver transistor in for the anodes just to see how it pans out, and done a bit of wiring. And if we look at how far I've got on the PCB for that, looks a bit chaotic, because of course the Nucleo and the displays aren't actually on the board, so we can mount components around their connectors. But I've gone for, as I said, through the hole just to make assembly easier. But on there I've also got to get 2 more transistors, and I want to get the power supply on there if possible as well. And I think I am going to run out of room. So I think I am going to go over to surface mount components, because they take up a lot less room. So that is my next step. I shall convert everything to surface mount, and as far as I know I'm going to have to do each resistor individually, which is a bit of a pain. And I'll bring you back and show you how I'm getting on then. Okay, so that's a lot better. The display is now mostly wired in with surface mount resistors and SOIC packages for the drivers, and you can see it takes up not so much space. These pin headers are for the light bars, for the range indicators. And I've just plonked them down sort of semi-randomly at the minute, and I've got the light sensors to put in, and these resistors here are just so I know which pins the GPIO ports are when I'm wiring it up, so I can wire it up in a vaguely sensible way that doesn't involve traces having to cross and go on the bottom layer, and so on and so forth. So onward and upward. Okay, crashed on and basically finished the top board without boring you with too much of me routing tracks and rerouting tracks and fiddling and fiddling. Is quite a time consuming process, but quite satisfying to do. You can sort of get quite involved in it, and I used to do it for days on end and be absolutely sort of bog-eyed at the end of it. Anyway, so here we have, I've got 2 schematics. That's the connectors. Those 2 big blocks are the 2 connectors to the Nucleo, and the other ones are connectors to the light sensors and to the LED bars. And the other schematic is the 2 displays, their drivers, and the transistors to drive the colour, the anodes to the displays. So how does that look? There we go, that's the board. Just unlock those 2 components. I kept catching them and dragging them. So there you go, that's it. Bit of a hack in places, but it's a one-off, and it's only LEDs basically. So I have design rule checked it all, and it's all good, and I will go back and recheck all the connections to the right places and so on and so forth, but I will do that after I've done the lower board, just in case I have to change something on this when I do the lower board as a result of doing the lower board, which is quite probable. Okay, printed it out real quick, just the top layer anyway, just as a sanity check to see if it all fits in the box, and at a moment of panic realised I'd forgotten that it doesn't fit in the box. At 9.9mm square, it just catches these ribs here, so excuse me, got a bit of a cold. I was originally going to take the ground plane on the back and just chop the corners off, and then I could bandsaw the corners off the board, but then I thought it's easier just to make it 9.9mm by 9.9mm and chop these bits of plastic off using a Dremel. Dremels! We will come to Dremels. But for now I think I am going to call it on this video and start another video for doing the bottom board. Also, I am going to test my circuit for driving the displays using through the whole FETs. I'm going to have to buy some new ones, surface mount ones, and through the whole driver chips again. We'll go out and buy some surface mount ones, but it'll allow to test the theory of driving these displays the way I've done it, rather than getting boards made and find out I've made a mistake and it isn't going to work. Not that that would ever happen to me, of course. So for this video, that's it. See you on the next one, which might be the bottom board of this, or it might be the dreaded Dremels. We shall see. So for now, that's it from Triplicate. Goodbye.